Hi, this is Skylar Huff from Coastal Alabama Community College, and this brief video is all about the Renin-Angiotensin Aldosterone system. This is all about a humoral control of blood pressure, and one of many systems is this RAAS system, or this Vasopressin system. So it doesn't just include this, but also involved, which are not directly related, includes epinephrine, part of that sympathetic component, and then directly the adrenal gland. So with all of this together, it increases heart rate. It also increases cardiac contractility and vascular tone. So keep all of these components in mind, which you likely learned in other classes and are learning about right now. So with this renin-angiotensin aldosterone system, it plays a central role in blood pressure regulation. So to help you out with this, renin is an enzyme that is synthesized to store, and then it's released by the juxtaglomerular cells of the kidney. And the reason that it happens, meaning you should know this, is it's in response to an increase in sympathetic nervous system activity or a decrease in blood pressure. It could also be a decrease in that extracellular fluid volume or even extracellular sodium concentration. So most of the renin that is released will leave the kidney and then enter the bloodstream, where it acts enzymatically to convert an inactivating plasma protein called angiotensinogen. So let's get into this once again with a little bit more specificity. So again, keep in mind that there has been at least a decrease in blood pressure and or a decrease in sodium ion concentration. There could have also been a decrease in blood volume. So, as is the case, from the kidneys, by way of those juxtaglomerular cells, they secrete renin. So this is all because of a response to those renal baroreceptors. So as this happens, in the blood, we have that renin that has been released that combines with angiotensinogen. So angiotensinogen is that inactive form. So it becomes activated once angiotensinogen comes in contact with the enzyme renin. So angiotensin 1 will then directly be converted into angiotensin 2. So the way that this has happened is it's almost entirely by way of those small vessels of the lung. So when those small blood vessels of the lung release this, they are catalyzed by the angiotensin converting enzyme, which you may have learned as being ACE. So if you're going to say ACE, make sure you know that ACE stands for the angiotensin converting enzyme. So this is present all the time in the endothelium of our lung vessels. So although angiotensin 2 has a half-life of only several minutes, renin persists in the circulation for about 30 minutes to an hour, and it continues to pause the production of the angiotensin 2 during this time. So as this happens, keep in mind that angiotensin 2 functions in both the short-term and long-term regulation of blood pressure. So as it's released and that conversion has happened, it is a strong vasoconstrictor, and particularly in your arterioles, to a lesser extent in our veins, but more importantly in those arterioles. So the constriction of our arterioles increases the peripheral vascular resistance, thereby contributing to a short-term regulation of blood pressure. So as this happens, it also causes aldosterone to be released. So as aldosterone is released, keep in mind that this occurs from the adrenal glands, and I'll call those the adrenocortical cells. So it acts on the kidneys, causing the conservation of sodium ions. And if you've ever learned it that way, water will always follow salt. So we also then conserve more water, and this happens via osmosis. So as that has happened, meaning that release of aldosterone, next up comes vasopressin, also known as the antidiuretic hormone. So this is released from the posterior pituitary gland in response to that decrease in blood volume and blood pressure. So this increase in the osmolarity of those fluids and other stimuli causes that. So as the ADH or vasopressin is released, this has happened, and it then ensures there will be that reabsorption of water. So with that reabsorption of water, it's all because of that vasopressin being secreted. Next up will be the increased thirst. As this has happened, that person will become more and more thirsty. And all of these in total will cause an increase in blood pressure. So the long-term increases in vasopressin, they cannot maintain that increase in blood pressure. But then again, though, it's all of these together that affect that patient. So if you have any questions about this, just keep in mind that the adrenal cortical cells are there synthesizing the aldosterone as it regulates the concentration of those mineral electrolytes, such as sodium, as well as potassium. So that aldosterone is going to cause our kidneys to conserve more sodium, to secrete more potassium ions, and then they respond directly to those changes. So this has been Scholar Huff. Hope that you learned something, and have a great day.